Today we're going to begin by talking about what we call function composition and what that looks like. So I just want to quickly recap what this means. This is not pronounced f times x. This is pronounced f of x, and it's just simply called function notation. It means whatever you get for f depends on what you plug in for x. So f is what we call the name of the function. Each output or answer that you get is dependent on whatever you put in x's spot. That's all this is saying. So we don't want to overcomplicate that. So I'm going to give you two functions. We'll call the first one f of x and the other one g of x. So you can see each of them have different formulas. So this is the formula for the f function, and this is the formula for the g function. So we're going to ask you to do 4 operations. We're going to ask you to do adding, subtracting, multiplying, and dividing. So if I ask you to do f of x plus g of x, it means I want you to add their formulas together. So the first formula, 5x, plus the second formula, which is x plus 2. When you simplify that, you get 6x plus 2. So that's the answer to this problem. Now, we don't always use this notation. Instead, sometimes we're a little lazy and we just say, you know what, let's add the functions that are dependent on x. So they'll put f plus g in its own parentheses and then the x in its own parenthesis instead of separating it. So it's going to follow the same trend for these other operations. So we're going to take our first formula and we're going to subtract our second formula. And notice this time the parentheses make a difference. So if you do not put your formula in parentheses, you're going to get a different outcome. So we would need to distribute this negative and then consolidate and get 4x minus 2. And the way they'll present that problem to you is they'll ask you to find f minus g of x. It just means I want you to subtract each formula. All right, now we're going to multiply, so we're going to take the first function times the second function, and we're going to distribute 5x into this set of parentheses and get 5x squared plus 10x. And again, the way they're going to present that is they're usually going to write f times g of x. It literally means the exact same thing. The last example is division. So we're going to take our first function and put it over our second function. Now it looks tempting. We want to cross out these x's, but we cannot because the 2 does not also have an x. So because this has addition, we cannot reduce unless everything has something in common. And usually the way they ask you to do this problem is they'll say, what is f divided by g of x? That just means what is f of x divided by g of x? So those are your 4 basic function operations. We just want to know how to interpret the notation. All right, so we'll do a first example. They're giving us a function f of x and a function g of x, and they want you to add the functions together. So the first thing I would do is kind of decode this to make myself realize this means f of x plus g of x. And then I'm going to substitute in my formula. So for f of x, I'm going to get 3 root x. And for g of x, I'm going to get negative 10 root x. Now I can go ahead and combine my like terms because these are the exact same radicand. 3 minus 10 is negative 7. And you just keep the root x. So we just did part A, which is find f plus g of x. Part B says we need to state our domain. So if you look at these problems, right, we never want our radicands to be negative when we have a square root. So I can only use 0 and higher for x. So all my x values have to be from 0 and on. Last but not least, they're just asking, well, what would you get as the sum if x was 4? Well, this is the formula when I added them together, so I can just plug 4 into that formula. You could plug it into the very beginning, but this will be quicker. So we're going to do 7 times the square root of 4, which is going to get us negative 14. All right, let's try doing a division problem this time. So we're going to do 6x over x to the 3/4. So I actually am going to use my exponent rules. X to the first is the same as x to the 4/4. So that's what I would do first. And then I would actually cross this one out and subtract it from the top using those exponent rules. So I will get 6x to the 1/4, which is the same thing as 6 times the quartic root of x. So my answer for part A is 6 quartic root x. So that part's done. Now I need to specify my domain. So if you look here, whether you look at the beginning or the ending problem, we have the same issue. This means the 4th root of x cubed. And because this is an even root, we cannot get a negative in here. It's the same case over here. We cannot get a negative inside the root. So we want to ensure that anything we plug in for x is always going to end up being positive. So once again, I have to use 0 to infinity as my domain. If I put something less than 0 in for x, I'll get an imaginary number. Part C says, what is the quotient when x is 16? So you already have your formula for the quotient. You can just go ahead and substitute 16 in here. The quartic root of 16 is 2. 2 times 6 is 12, so I get 12. So what I'll do in my next video is take you through a word problem, and then we'll look at some different ways to do these composition functions. So we'll kind of take it up a notch.